Alright, what's up? Today I'm working on my NES emulator. Um, I'm not super far. I've implemented the 6502 CPU and I'm working on the PPU right now. Just a picture processing unit. It's what displays graphics on the screen. So there's sort of two parts to the PPU. There's background rendering and foreground rendering, which are the sprites. Like anything that's active on the within a frame is a sprite. And I have background rendering mostly working. I'm working on trying to get sprites working now. So I can show you what it looks like right now. Yeah. So I've been using Donkey Kong as a test cartridge. So first of all, this is fucking sweet. Like, this is just like a random garbage. Well, obviously it's not garbage because it's so regularly patterned, but this is just like residing in memory at startup. It's like displaying what's ever in memory. And I don't really know why it ends up looking like this, like with these regular bars. Like, I kind of want to like dig into like why it looks like that, but anyway, that's a whole other thing. So this is where like the NES like screen, the output of the PPU will be, and then I have this little debug sidebar over here. This shows the state of the CPU. So these are all the status flags. So this is a single register, and this is like each bit. It's an 8-bit CPU, so you have 8-bit registers. Hold on a second. Alright, sorry. So it's an 8-bit CPU, so it has 8-bit registers and a 16-bit address bus, so like program counter is 16 bits. So here's the program counter. It has 2 registers, sorry, 3 registers. There's like the accumulator, and then X and Y are like used for like indexing usually, but I mean you can use them as general purpose. And then there's a stack pointer, you can see here. And then below that is going to be like a dump of where you're currently at in memory. So let me just start running it. So if I stop it here, you can see like the program counter is at this address, so you can see it here, and then like around it. And then I disassemble like the bytes at that memory to get like the assembly representation of the instruction at that address. So like you can single step through it, or step frame by frame, or just run it. So you can see I got background rendering kind of working, and this is why it's a good test kind of, because Donkey Kong has like a demo mode when you start it up. And like interestingly, this animation is like not a sprite, it's happening in the background. So like, I mean, I'm not gonna go explain like entirely how the NES works right now. Like if you want to know, go to the NES Dev Wiki, because this is where I learned pretty much everything. They have a guide and a ton of info. Like the people who spent years working to figure out this information, largely by reverse engineering, a lot of it is pretty rad, and they compiled a ton of super useful information. And this is where I learned basically how the NES works. I guess separately for the 6502, there's like a whole other site for that. Yeah, this site is really good if you want to learn about 6502. This site for the NES. But anyway, this is happening in the background, and so I kind of have this sort of working. But you can see, like in the demo, Mario's supposed to be running around. There's like a fireball that comes out of the oil can, and all the barrels that he throws, those are all sprites. I'm trying to get those working, so that's what I'm working on. Yeah, so let's try to figure out what's going on. So I've started working on this a bit and just am in, so let me check out kind of the current stuff. Yeah. Let's reload this and go in here. So let's see, like where a pixel gets rendered, I'm trying to start rendering sprites as well. So this is just rendering background all the time. So if I disable it, it's going to try to do with the sprites on top, but it's fucked right now. I'll show you. It looks crazy, but something's definitely fucked. Yeah. So I fucked a lot of shit up. We gotta figure out what's going on. I mean, it's also strange that like huge chunks are solid color. Like it's trying to render a sprite like over all of this, I guess. I'm not sure. I would expect an error to be like in a sprites area at least, but I definitely fucked some shit up big time. So let's figure out what we're doing. Alright. So basically, in order to render sprites, there's two phases where rendering happens, or two phases that like come together in order to render sprites. There's so this is a really nice graph that shows sort of how the PPU is functioning like cycle by cycle. So like each row is a scan line because the PPU like outputs pixels like in step with the scan line of a CRT. So like each row is a scan line and each column is a cycle. And the visible section, like the PPU outputs 256 by 240 pixels. So this is like the visible section in here, but then it also like has cycles outside of that where it's doing extra work. Like often in here it's computing like a background tile for the next scan line. And anyway, for sprite evaluation, that happens in this section. So this is what cycles are this? Like 65 to 256. It's evaluating sprites for the next scan line, and then once it drops down to the next scan line in the visible section, it's like rendering sprites there if they are there. And like sprites are represented in a section of memory called OAM, which is Object Attribute Memory. And inside of there, this is what it looks like. It's like each entry in this, so the OAM memory is 256 bytes, and like each entry in there is 4 bytes long, where each 4 byte entry represents a sprite, where the 0 byte is Y position, byte 1 is the tile index, 2 is a set of attributes, like whether it's flipped horizontally or vertically, and like a priority, whether it's behind or in front of the background, and then the last byte is the X position. So when you're doing sprite evaluation, basically what you're doing is searching through, so 256 bytes with 4 bytes per sprite. That means there's 64 like total sprites that can be stored in memory. And then there's a secondary OAM in the PPU that stores 8 sprites, because on a given scan line it can only render 8 sprites per scan line. So in this sprite evaluation, it's looking for the first 8 sprites that will be visible, and it stores that in secondary OAM. So then on the next scan line when you're rendering it, it uses that set of 8 along with the attributes of each one and the background tile to sort of choose what gets rendered at that pixel. It's either, you know, the background, a sprite, or nothing, a transparent pixel. So let's take a look at the sprite evaluation. I guess that was the right file. So if we look at the rendering tick, this sort of breaks out the work that needs to be done on each cycle of the PPU. Actually, one thing I didn't mention is, like, I'm not currently implementing this the same way the actual PPU does sprite evaluation. For the background, I do it like per cycle like this, but for the sprites, what I'm doing is, like, at the end of the visible section, so like on cycle 257, that's where I'm evaluating all of the sprites all at once, instead of doing like spreading the work out between individual cycles. And so that happens in evaluate sprites. Yeah, so you can see if it's cycle 257, we just do all the evaluation there. So if we look at this function, what is this comment? Oh yeah, I need to handle that. But anyway, so this is just, so that secondary OAM where there's 8 sprites, you're just initializing it, I'd say clear, but it actually sets each byte to FF, which I believe the reason for that is because, like, you're trying to find visible sprites, and so the first byte is the Y position. If it's FF, it's never on screen, so it'll just throw that away right away. So you initialize it, then you're going through all of the object attribute memory here. There's 64 of those. That's why you step by 4. There's 4 bytes per sprite. And then, so for each one of these sprites, you check if it's going to be visible on the next scan line, which is what this does. And then if it is, you add it to secondary OAM, basically is what this is doing. The other thing I'm doing is, like, right at this moment, I'm populating the shifter registers with the pattern data for that sprite. So the way this rendering works, let's go look at rendering. This is the graph I'm looking for. So the way pixel data is stored is, as the PPU is, like, ticking each cycle, is there are these shift registers. So for the backgrounds, you have these 16-bit shift registers. It's basically like a parallel to serial thing. So like each tile, like, let's see if I can run the emulator. So, like, in here, they're really small, but, like, each one of these 8x8 tiles, like, okay, there's also an 8x16 mode, but just in general, there's 8x8 tiles. So tile is always 8 pixels. So when you have, like, a background tile, the way these shift registers work is, like, every 8 cycles, you will load the so there's 16-bit registers. You load the low 8 bits with new data for the next pixel that you're going to render, and then the top well, the entire register gets shifted by 1 bit each cycle. So you read this like high bit, and like that's 1 bit of your pixel data for that cycle, and then next cycle you shift off the whole thing down. So you do that 8 times, and then you load in the next set in the low 8 bits. Then you shift 8 times and keep loading in. And so the same thing happens with the sprites, except you don't have 16-bit registers for sprites. It's an 8-bit register. And so yeah, you basically need to load in the data for the sprite into the shift register. The other thing is that the sprite can be sort of anywhere on the scan line, right? So with the backgrounds, there's some data that like figures out where the X position is, because there's scrolling that can be happening. So there's a lot of calculation done to say like which pixel in the tile am I going to render. For sprites, like the game programmer keeps track of the X position. It's in the like sprite attribute or OAM. So what you do is when you're rendering a scan line, and you know there's some number of sprites on there, up to 8. For each sprite, it will have an X position, right? And so as you increment your like cycle of the PPU, you decrement the X position of each sprite, and when that reaches 0, you know like your PPU cycle is at the current, that whichever sprites are at 0, you're at that sprite now, and you can start rendering it. And once that happens, then you do the same thing you do with the background rendering. You start shifting. Each cycle you shift 1 bit out of the shift register, and doing whatever calculations you need to do with that to decide whether the sprite pixel gets rendered here or not. Okay, kind of understand what's going on now. So like this is where I'm loading the data into the shifter. If this particular sprite is visible on the next scan line. So and then keep doing that. I don't know why. So in the rendering tick is where shifting happens. So this is what I was talking about with each PPU tick. For each of the 8 sprites that are in the secondary OAM, you decrement its X position if it's greater than 0. Once it hits 0, you start shifting a bit out of the shift register each cycle. Right, so that happens in the rendering tick. Then after the rendering tick is render pixel, which is where you try to decide from the background and the foreground. Foreground is like also, sprites are also called foreground in some places. There's synonymous. How did this get up here? So what do we do here? We're assuming that you have already loaded the pattern, like the 8. A single row of your pixel is in the shift register. There's a mosquito in here. So you're getting the high bit, so you have the high byte and the low byte, right? And so you get a bit from each of those. I don't think I'm going to go into this right now, but basically the way rendering in the NES works is there's like 2 bit planes, and you combine them to form the final pixel. So yeah, you're getting the high bit out of that, which combined gives you a palette index. So yeah, you have a number of palettes, which you can see here. Like this also renders, let me start it running. Once the demo runs, it'll populate the palettes. Yeah, so there's 8 palettes in memory. Each one is, well, it's 4 bytes, but they wrap, so like byte 0 is like the background color, and then so every 4 bytes, so byte 4, 8, those like also refer to this background color byte. That's why you're only really seeing 3 colors here. Anyway, so you have these palettes, and you can index into these palettes, so you can have like the same sprite with a different palette applied to it. So for sprites, it's the palettes 4 through 7 are sprite palettes, and then 0 through 3 are the background palettes. That's why you have this +4 here. So this is the palette number, and this is an index into the palette. So this is what ultimately gives you a color. So I don't see anything immediately off here. This seems correct. But then how do we choose, which one to render? So this is going to be the final like palette number and index. What happens if we just always draw a foreground? So like only ever draw sprites. Maybe that will reveal something. Like it will probably just draw the garbage we were seeing and not the background. Once it goes into the demo. Yeah. So yeah, this is what my sprites are doing right now. They're borked. So, what's the problem? Let's check out... So one thing I know that's correct is the OAM attribute memory. So like the sprites and memory are okay. I know that. Because, let's just jump back to here. So before I showed you like the disassembly was here, and like the instruction pointer would point at current instruction. Right now this is swapped out for an output representing object attribute memory. This is like the starting at 0, so you only see 10 entries in OAM. But this is a X position, Y position, attribute, byte, and a... Sorry. I don't remember if it's attribute. I think this is a tile ID, and this is attribute. Yeah. So X and Y position. So on this screen, actually, there's a sprite that's here, that's where you select which mode, and you can toggle that by pressing select. So as I do that, you can see it's going, starts here, 127, 143, 159, 175, and back up here. And then also if I can just go to mode 1. If I hit start to play this mode, it's really weird playing this without seeing the sprites. So Mario's going to be down here, right? This is his position. As I press the key to move, you can see his X position increasing. If I go to the left, decreasing. I can jump, you can see the Y's increase and decrease. Yeah, so these all look legit. What else was I gonna also, like, I know that A2, right, would be A's are vertically, so like it's around A is here, 2 is 1, 2. It's this asterisk star character, which I know to be like what's supposed to be here. So like the star would be here, that's the ID into this, the tile ID is here. So this is correct in object attribute memory, right? So okay, that's not the issue. The issue is like choosing which sprite to display on each scan line, right? So we can check out evaluate sprites, see what's going on here. I don't think, I'm not supporting 8x16 yet, so I can hardcode this to 8 for now. I don't think that's really what's going on. But yeah, I just noticed that. I want to check that. Still nothing here, so it's probably gonna, yeah, same thing. So right, so we're initializing this. That's okay. This doesn't matter because I'm not doing anything with sprite overflow yet. Right, for each OAM entry, pull the sprite out. Right, so this is saying if this sprite is going to lie on this scan line. So the way you do that is, like on this scan line, say there's a sprite like here, you take the scan line minus the Y position of the sprite. It basically tells you like how far into the, potentially how far into the sprite you are. So if that's great, it has to be greater than 0 or else the scan line is above it. And then you know the height of the sprite. So if it's within those, then you know that the scan line like basically collides with that sprite. So is that implemented right? Like, so you're saying on the next scan line, that's what this is. Right, because evaluate sprites is happening here. So like this row has just rendered. You get to here, you're calculating the sprites for the next scan line. So it's scan line plus 1 will give you this scan line. You subtract the sprite's Y position to give you like where you are relative to the start of the sprite. So if that's greater than 0, greater than or equal to 0, and less than the sprite height, and you don't already have 8 sprites, what do? Well, we're going to add it to secondary OAM, but I'm also just getting the sprite pattern right away. Is it okay to do that here? Sprite evaluation. So, you scanline the PPU reads OAM to see what to draw. It clears the list of sprites. It reads through OAM, checking which sprites will be on the scanline. Finds the first 8. If 8 were found, it sets sprite overflow. Using the details for the 8 or fewer sprites, it determines which pixels each has on the scanline and where to draw them. During all visible scanlines, PPU scans OAM to determine which sprites are on the next. Yeah. Yeah. So I'm not doing it cycle by cycle, but that's okay. So yeah, it's saying on cycle 257 is where the sprite fetches happen. So yeah, it's saying like actually in the actual PPU, this is where the clear happens, evaluation happens in here, and then from 257 on, is that right? Yeah, 257 to 320, and this blue section is where these fetches, yeah. So where you actually get you're populating the shifters. So the way I'm doing it there is fine. So we're populating the shifters. Is this right? So how do we get the address? Well, you're taking the sprite table from the control register, which is what? Sprite table. It's bit 3 in the control register, which I think they talk about here. Oh, it's in OAM. Right, so this tile number of this sprite within the pattern table selected in bit 3 PPU control. So So the pattern table is bit 3, right? The pattern table is either the left one or the right one here. You have two of these pattern tables. So it's either the start address, you know, from here to here or here to here. So where are those in memory? Pattern tables. Let's find a memory map. So you're from 0 to 0FFF is pattern table 0. And then from 1 to 1FFF is pattern table 1, right? So if this control bit is set here, then we want 1000 to 1FFF in hex. So what does that look like? So like hex 1000 is what? This. Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry. It's 4, 8, 12. So that seems right. Shifted by 12 bits. Right, so there's that. That will give you this. Then you OR that with the tile ID times 16. So why did I do that again? The tile ID is yeah, the tile number within the pattern table. So bank 0, 1000 of tiles. Oh, I see. Okay, all of this is for 8 by 16. That was confusing. So the tile number of the sprite within this pattern table. So this ID is an index, and we're doing 16 because each tile is 8 by 8, right? And let's see. So each tile in the pattern is 16 bytes, made of 2 planes. So the ID is the ID in bytes. It's a byte offset into the pattern table. So that's why we multiply by 16, because each tile is 16 bytes. Okay. So this says which pattern table. this is index into that pattern table, and then this is an index like into that individual tile. Right, once you've found the tile, your scan Y is a value between 0 and 7, right? And since 8 bytes per plane, and you're only getting the low byte, which is the low plane, that means the Y will give you which row of the tile that you're in. Okay, I think we understand that now. So that looks good. And then we can calculate the high by just adding 8 because of this bit plane. Like this, whatever row in the low bit plane you're at, if you add 8 bytes to it, you will always get the corresponding row in the high bit plane. So we don't have to calculate this one. We can just add 8. Could it be the bus read that's... Bus read... Yeah, I mean, so there's a possible... I mean, well, that wouldn't be it because like all of the background rendering is working. But right now, I haven't implemented mappers. So NES cartridges can all have a unique memory mapper chip in them that handles calculating addresses of... So in an NES cartridge, there's like character memory, which is the tiles, like the graphics, and then there's program memory, which are the instructions. And so the mappers can do different calculations to actually map accesses made to the cart by the CPU or the PPU to anywhere it wants. So there are a lot of different ones. So if you're writing an emulator, you have to emulate those as well. But for now, I'm just doing like what is called mapper 0, which is basically no mapper. It's just whatever address you ask for is actually the address you get. I don't think that's the issue because if the mapper was the problem, then like all the background rendering would be borked too. And like, I actually don't remember if like instructions are also mapped differently, but in the case they are, like the instructions would be fucked too, but they're not, so I don't think it's the mapper. But you're saying like, I want to read this sprite address, which will be a value definitely below 2000 because that's where the pattern tables live. So yeah, correctly, it's a cart read anyway. So let's check this out. So yeah, you're just pulling character just reading Then you're stuffing that into a shift register. So we should only be getting 8 ever. Right? We can just say sprite count. Do a little printf debugging. So 8. Hold up. It's getting 8 at some points on 1. That's good. Alright, it's getting 1 in a lot of places, which is what I would expect. On the home screen, the menu screen, but I wouldn't be expecting it to get 8. So maybe we jump in here and, well, I just want to put a breakpoint here. I'm going to jump on the debugger. So I just need a statement here, but I need it not to be optimized out. So I just learned, I've been learning a little bit more about volatile. 69, of course. So this should make sure that the compiler doesn't remove this. Like, since this X isn't going to get used, the compiler would just be like, dude, you're not doing anything here, and optimize this out. But if I put volatile, it should force it to keep that in there, so maybe I can put a breakpoint here. Let's try that. So I gotta make a debug, so I get debug info in there. Then let's just go in GDB. So where do we want to break? 301. 301. Then let's see, we're gonna run with oh shit, I should have ran this in RL wrap so I'd get anyway, what is it? NES ROMs Donkey Kong. So we're here, we start running. Is it running slow as shit because it's being debugged? What is this? This is interesting. Is the timing all fucked up because of debugging? Jeez. I feel like it's in a loop waiting for like the initialization sequence. Like the PPU has to set like VBlank in order for the CPU to like initially jump out of this loop. I mean, that's typically what the game code will do. I think that's what's happening, but I think like being debugged has made this thing slow as fuck. Or maybe it's like fucked with some memory. I really don't know what's going on there. Honestly, I'm not a GDB pro at all. I mean, what was I trying to pull out of there? It's like, okay, if our count is 8, I want to know what is in there. That's fucked, really? Yeah, give me that shit. Wait, isn't there a way you can like run a program and then like attach a debugger to a running process? Is that a thing you can do? Attach PID. Can we just do that? So let's do this. Wait. Is this just because we have debug symbols? What the fuck is going on? Debug. Oh my gosh. I know what's happening. This is dumb. This fucker. How big is that shit? $451 megabytes. So early on in testing I was logging out like all the instructions and like CPU state to help debug, and so it's I/O that's slow. Like it's just trying to write to disk. That's why it's so slow. Alright, so we don't need this anymore. I mean, we were already had debug symbols the whole time, so yeah, we don't need that. We just make normal GDB. Let's do the RL wrap one. Now we should be able to do previous things, right? History. Damn it, I guess not. Where are we at? Here. Run. Yep. That is what's going on. So, can we... Alright. So, we're seeing 8 sprites here somewhere. Why? Let's go in here and see what's going on. So in here we have like a sprite right now, right? Optimized out. Fuck. Do I have... What's I? $261. Yeah. Okay. I have a comment about this, I think. So it's trying to evaluate sprites on scanline 261, but this is a pre-rendered line. There's no sprites here. So it doesn't do OAM clear and sprite evaluation, but tile fetches still do occur. That's curious, because how the fuck do you... So you're saying... Wait, okay. So on 239, this occurs, which will evaluate for here, I guess, is what they mean. But the fetches still occur here? Hold on, so... yeah, here. Secondary OAM clearance sprite evaluation do not occur on pre-render scanline, but fetches still do. So the fetches are here. Wait, this is sprite evaluation. This is fetches. Alright, I don't know, what's the difference if on 239 we do the fetches, because we are doing them here already. Presumably for, like, the first scan line. So then we go through all the, this is like the v-blank period anyway, and as we're going through here, we get to the last, or the pre-render line, none of this evaluation happens. But then we fetch presumably the same data that we fetched here. Are there things that could have changed between there? I mean, all the fetches do is use addresses calculated for... So, let's see, can we just say if the scan line is 261, we just return. We're not going to do that. So, fetches should still occur. So we'll leave this comment in. Wait, do I always have that? Oh, so you have reverse search in there. Anyway, NES. We increased lines now, didn't we? We want line And notice we don't hit that breakpoint anymore because there's no longer 8 sprites everywhere. That's good. Okay, so I mean that's a small thing. Okay, but so on the main menu, right, it is getting 1 sprite. So let's look at it. Also, this sprite, can we call this volatile? So I can look at it. Is this like normal to do debugging? You can do init scripts for GDB, I know, so I don't have to type this shit every time. That's what I was trying to do, RL wrap. It's supposed to give you like history, so you can type the same shit. I suppose it doesn't have any memory outside of it, so I can do it within a run. Oh well. Okay. It's hot. It's fucking hot. Can we just continue a few times? So, there should be a sprite here. There's one of them, right? We have one. Sprite is optimized out, but I frickin' marked it volatile. Alright, can we break it like 281? Alright, we got here. Now it's the sprite. So it's at 127, 56. Tile ID is 162, adder is 0, right? Is A2 162? How do I do this? Hex for 162. A2, okay. So we have the right data there, like we got the sprite we wanted out. Let's run an instruction. What is sprite adder low? It's 32. I mean, it's reasonable. It's an address in the first pattern table. It's 0. Huh. Hold up. I mean, what is sprite tile ID? Two 592. Can't you like print in hex? Is it like that? Okay. This thing. That makes sense. I mean, this address is hex 20. I mean, so if I know this is the pattern table I'm trying to read from, right? This address should be A2. Like, isn't 20 gonna be... This is wrong, actually. Hold up. Scanwise optimized out. Right, but that's just gonna be an index into the tile. I feel like I need to add that. Like, won't ORing it do the same thing? Alright, like, what if we OR that with, like, this, right? So ORing it, we get that. we add it, we get this 1, 0. It's 0 with the carry, 0 with the carry, 0 with the carry, 1. It's not the same. I'm thinking like maybe we need to add that. Still nothing. Still garbage. Is this just a timing issue? Because, like, we're not getting anything here. What if it's like a OAM timing issue? What I'd really like to get is on this screen just to get this guy to render. So we found that like the sprite we're pulling out here is legit. The address we get, is that legit? How do we check, right? Well, if you can get the address, since you're running with no mapper, you know that that address is like a direct address on the PPU bus. So, and it's less than 2000, so it's for sure going to the cartridge, and it's just directly in cart ROM. So, like when you read a byte out of there, it should give you legitimate values. I think this is actually the same in the case that, like, there's no, it's with both ones, which in this case you have what, hex. So this is gonna be basically from here, to up until here. Well, these are, we're not in hex, so ones, damn it. Okay. So we have this bit plus tile ID times 16 So it's gonna be a multiple of 16, which is here, right? And then scan y is max 8, so it's here. So ORing works fine actually in this case. This damn mosquito. I think I need a break and I need to get some tea. Yes, I do need that. So, alright, we back. I think I figured out what my issue is. Addresses are 16 bits, folks. The fuck was I thinking? Big old dummy. Yeah. So let's figure this out. I wonder if it'll just work now. Nope. Interestingly though, I think this is where the first sprite would be, right? So maybe we're getting close. Right, we've just made it much worse, that's all we did. Alright, but we did, wait, did we make first? Yeah, we built it. Yeah. Alright, so we don't need volatile. We don't need that anymore. So now, can we at least get like a byte out of memory? Let's check this. We're going to break. Where do we want to break? 280. We hit it. We hit it. We hit it. Alright, yeah. So, let's get the address and then the data and see. Alright, we got some bits. We got some bits now. So low has some shit and high does not have anything in it. Does that make sense? I'm not sure. Let's see. So the low, let's see. The low bit plane controls the color, bit 0 of the color. The second plane controls bit 1. So I suppose it is possible to have Stupid mosquito. Have bit 1 be 0. What if we do... So 146, what is that? Jesus. 92. Alright. 92, what is that? 9, 2. Right? That's plane 0, plane 1. That doesn't seem... It's like what we would be well, actually maybe. Maybe there's like one here, one here. Can we get somewhere in the middle? Let's see, what is scan Y? It's optimized out. Well, I have PPU scan line +1 minus right Y. Can I just print that? Zero. $127. $126. So can we keep going? $126. Why do we keep hitting this on 126, right? What's happening here? That's a terrible font color. Break it 265, delete 1, continue over here. Now we're at 127, 28, 29, 30. Sneeze. Alright, so here now let's break 280 and continue. We're not hitting it. you're not hitting it at all. Huh. So, huh. $126 is the only place we're ever hitting it. Why is that? It would seem, right? So, count less than 9, and we initialize count to 0. So let's not count. Scan Y has to be greater than or equal to 0. Hold on. Sprite height is an int, okay, so it's not like a... Gotcha, bitch. Fucking mosquito. That shit. Fuck that guy. Okay. So you're saying where the scan line is. I wish I had a good like drawing program. I don't really know what to use. Online drawing. Sketchpad. Alright, so let's see. Screen. We have sprite. We have this scan line. Boop. Right. So this is the Y. This corner point. This is scan line. So say this is 30. Say you're like 3 pixels down. It's 27, right? So you're saying you want to take your scan line minus that. So in this case that's 3, which is correct, right? That means you're 3 pixels in. Height is always 8 for now. So is that less than 8? It is, so it should be... I mean, that calculation's right. Like if it's less, right, you get a negative number here, so the loop is not entered. If it's 40, let's just say 47, you get 20, which is greater than 8, so it doesn't enter. So this calculation's right. It's implemented right. So scan Y greater than or equal to 0. Less than 8. Hold on. Oh, that's why. Look at this. I only ever evaluate it. Wait, no, that's right. On cycle 257, but this is on scanline. Scanline's less than 240. So that's right. 0 to 239. This happens on 257. So you have the scan line you're at. So that's okay. So yeah, it should be fine. Could it be that it thinks there's sprites here? Because this is going to be, so OAM2 is going to be initialized to FF, right? And then here I'm checking if index is not 0. I suppose here I need to go through, like, I need to know maybe how many there are. So let's just say there was 1. So then, like, the main menu would work if that was the issue. Well, but then it's still gonna always think there's 1, always. What I'm trying to get at is maybe we have to keep track of, like, the actual count. Let's try this. Sprites. Sprite count. Sprite count scanline, something like that, or like scanline sprite count. I don't know, we'll call it that for now. So evaluate, we're gonna say sprite count scanline 0. So instead of count here, we'll use this. So how about that? And then in the pixel, that's less than PPU sprite count scanline Holy shit. Okay, well. I mean, there's a sprite there. I mean, this is encouraging. A little bit, because it's kind of like, it's like the first line where a sprite would be. You're getting some data, but it's like only on the first like the first scan line, and it's the whole scan line. Why is that? Maybe what we want to do is take a pointer to this. Point 18 pointer count equals this. Just to make it writing it easier, but I honestly don't know if it's any better than where you're gonna have like count. Is that any better? Just leave it here. Okay, now, how come you're only ever finding sprites on the first scan line? Well, here's what we know, right? If scanline is equal to 126, just do this in line. Obviously, this needs to be 69. So we want to get to 126 where we know there's going to be a sprite, and then go to, you know, the next few lines where the same sprite should show up, and figure out, you know, what values are in here that aren't what we think they should be. Yeah, instead of running it, we want to debug it. What is this? This is 269. once we're back here. Can we now break 272? Delete 1. Continue. 126. What? What the fuck? Oh, cause like we're in the loop. We're just jumping up. Is that why? Okay. So we're 127. What happens? Sprite is all F's. Here's what we want to do. We want to get here. We actually want to get here. 126, right? What's I? 0. It's the first sprite. Alright, so the zeroths, right? That's good to know. So now we can go 263. Alright, we're 127. Why would that be? When is OAM? Wait. That part's right. So when we enter this loop, right? It's all F's now in OAM, right? Where before it was something else. I is 0. Scanline's going to be 126. Sprite has some shit in it, right? So how come on the next scan line OAM has changed? Why that is? I think I might know why. I think I need to delay the CPU. Since I'm doing okay, so the main way that the CPU like game code puts sprites into OAM is not by writing bytes to the PPU directly byte by byte. That can be done through like writing to the OAM register of like PPU in the PPU's address space, but the way it's normally done is through a DMA. So what I'm doing is doing that transfer all in one go, right? But on the actual PPU, that takes like 500 cycles. And maybe that's what's happening, is like the timing is off, so it keeps doing OAMs, maybe. So DMA, most programs copy DMA and then they do a DMA transfer to the OAM by using this register. So writing N to this register. So N is going to be like an offset onto the stack, yeah. And so you say this is my offset, and like I just want you to copy 256 bytes, right? This will take 513 CPU cycles, because so while this is happening, the CPU is suspended, right? So it takes 513 cycles plus 1 on odd CPU cycles. Okay, so when I do a DMA, which is probably either in the CPU or the bus, actually DMA like case insensitive here, okay. So when the CPU writes to 414, we copy 256 bytes, right? But what we need to do is then pause the CPU. So how do we know on the CPU side when we do a DMA? Like, it's just gonna be do I know if it's even or odd? I do not think I'm cycle accurate at this point, but what we need to do is say if you have a write instruction pushing on the stack. Should be like, could be one of these stores. I don't know if it's best to, like, from the CPU try to detect, like, okay, if you write to this, you know, if you're writing to 414, you know, halt. Or if in the bus we should say, okay, if we get this, do like CPU suspend and then like pass it number of cycles, but like the bus doesn't really know. Fuck, I don't even have the CPU here. So early on when I was writing this, I was passing in the CPU to most of... So the CPU isn't global like the other chips are. Like I made... Well, yeah, the PPU is like a static. It's not global, it's static to this file, and so you can have functions in here that expose like things you can do from the outside world to this PPU, and I've done that with every other chip, but like when I started with the CPU, I didn't do it that way. It's something I need to address. But anyway, I think if you do a DMA, do something here like cycles. Yeah. So here what you do is like every time you do an operation, an instruction takes a certain number of cycles. So like when you execute the instruction, you figure out how many cycles it's going to take for the CPU, like a real 6502, to actually execute that, and then you sort of wait for that many cycles. Like you do all of the, you know, work all at once, then wait for how many cycles it would have taken. So what we need to do is have a way to say like, okay, for this transfer, you need to like make this op cycles 512. And right now from the bus, we don't have access to the CPU. In fact, I mean, I quickly want to... Like, I need to know which write. Yeah, I mean, I need to expose it here. I mean, maybe you could just have a thing that's like CPU suspend for DMA, right? And then CPU will be able to tell if it's on an even or odd cycle and suspend for 512 or 513 cycles, right? Okay. then for DMA, so we're gonna have to, oh boy. I think we're gonna have to do a chunky refactor where we pull the CPU out. So I guess for DMA, we just want to say if CPU, what is it? Cycles. You know, what we could do is here say before we execute, we do this. We say like if op is one that can write to 414. Can you read from 4014? Yeah, but it doesn't make any sense. So like, if they were to do that, that's an error, so they probably won't do that. So for a quick hack, can we do this? Can we say if adder is 4014, do that for now. Do a neat 512. Interesting. So, yeah, it doesn't seem to be an issue with the timing. Are we even getting this DMA? Getting these DMAs, so we're doing these cycle pauses. I was hopeful that, you know, that might be a source of the issue. There's no change at all there, so big ass table somewhere. There it is. Yeah, these are all the execution functions. Okay, I'll leave that in just to try to reduce the number of variables that I'm working with. Times it shit. I need to get some food at some point. Okay, so still have this issue where the only time we're seeing OAM gets changed, right? Why? Why? Do we do anything with sprite here? Right, we mem copy out into OAM2. So it's not like the I mean, can't we do like watch OAM to see when it changes? Like watch, set a watch point for an expression, stops execution of the program whenever the value of an expression changes. If other location is given, this evaluates expression and watches the memory to which it refers. So I mean, I want to first of all, we can come in here and break like here again. I should probably order some food so that I can eat something tonight. I have no oh, I have some spaghetti. I'll eat spaghetti later, I guess. So we got to this breakpoint. If we run this thing, okay, we're here. If we go in here, we want to see. Can we watch? Oh wait, PPU OAM. So we changed OAM somehow. We changed OAM. Wait, did I fuck up like this memcopy or something? Memcopy is dest source. God damn it. I did source dest, didn't I? God damn it. Okay. Well, I'm just an idiot. Do I have any other mem copies in here? No. Let me see. Like. STB image is not me. I only have the one. Wait. Yeah. Okay, so I'm just a big old dummy. And now it's even worse, right? Wait, that's interesting. Why isn't sprite palettes initialized here? Oh, it is. Like, pink is the color I think it's supposed to be. Right? I think. Like, I think I have like the FCEU emulator installed. Alright, so what happens when we get to the actual thing? Oh shit, look, it's Mario! What the fuck? What the fuck? What is going on? I mean, we're getting closer. That's goofy looking. Like, what is that move? What the fuck? So I feel like the X positions are clearly fucked. The Y positions are like roughly correct. Like what if yeah, check it out. Like I can select. What about if I play and like I control Mario? jumping is like going diagonally and affecting like all the sprites. Okay, weird stuff, but this is better now. Should have cooked rice. Alright. So, what about this thing? So the interesting thing is that they're always like it's rendering always from like pixel 0 up to like from the first scan line it's always rendering, which is obviously not right. Why? So rendering tick. So, okay, if you're in the visible region, for each sprite that's already in OAM2, right, which is this, if it's greater than 0, decrement it. Otherwise, do this. Is it possible that somehow it gets set to less than? Well, it's unsigned, right? It's unsigned, so clearly greater than 0. So it could be equal to 0 here, in which case you start shifting. So for each sprite on the scan line, I see. So hold up. Like no matter what, we're always outputting, right? But here we need to say like only start outputting if the x is 0, 2, right? Yeah, so I think in here, in the actual rendering of the pixel, we only render if this sprite x 0. Right, so that will take care of everything above it. Everything after it, this will still happen, but since you're doing left shifts, it's going to shift zeros in, so there'll be zeros. So you get 0, 0, index will be 0, yeah. So that should be fine. It's over here. I feel like these are on the opposite side. Starts over here. Sorry, this is just going to be loud again. Sorry. Yeah, he starts over here. These are on opposite sides. What the fuck? On mine, he's starting over here. Also, is that even show up on my screen? It's on the wrong side. Why? Why you on the wrong side? I mean, does it have something to do with like operator precedence that I'm fucking up here? Like, I don't think so, but sometimes operator precedence is a bitch. Nah. It's not that. So hold up. I mean, this, I don't think that's it, but like this rendering tick also happens on scanline 261. Which obviously wouldn't affect anything. Okay, it's gotta be this, right? So like you render, which pixel do you render? Well, alright. So rendering tick. Ah, okay. This should probably be this new PPU sprite count scanline, because you only want to decrement the ones that are there, I suppose. That's still not going to affect those, I don't think, but so that's good at least. Then, I mean, that's not gonna work. But makes the loop smaller, I guess. Right, it's gonna. Whatever pixel value is out, which you know is, in this case, is 56. So like for each of these cycles, it's gonna go down by 1 until, so after 56 cycles, it'll be at 0. It'll start shifting out. And can we just double check that? We can say PPU scan line is 261. Sorry, 126. Can I just do volatile X? Wait, cancelable. Fuck. What I want to do is just happens a shit ton of times before this is actually rendered. So I guess first you want to break here, 269. The point of all this was so that I can see the X sort of decrementing. Show sprites not enabled right now. Alright, we're on 127. There's one here. Damn it, it's because I'm not stepping in, right? X is 250. What? I'm getting 162. 250? Is my mem copy borked? What the fuck? Where the fuck is that sprite coming from? All I need to do is fucking break here. Where the fuck is that sprite coming from? I'm so confused right now. No, we want to quit. We just want to... Hold on. I don't think we need that anymore. Can we just break on 418? How many cycles do we need to go until we actually... Like, why is this happening in the beginning so much? This is so fucking frustrating. So we did fucking need this because we have to break at 269 first. So 162, adder's 56. Wait a minute. A2 is 162, isn't it? A2. So my data just got jumbled up. What the fuck? How? So it's this copy. Wait, what the fuck? Where's this +1? Add sprite to secondary OAM. Plus I. Somehow this shit got... What the fuck? Holy shit. Holy shit. Look at that. Oh, fuck yeah. Look at that shit. That's okay, because we haven't done like flipping. I think that has to do with horizontal flipping. That sprite's fucked. Fuck yeah, look at that shit. Yeah, I can play? Let's try to play. gosh, look at this shit. Like, walking left is fucked, but what did I just hit? There was like an invisible sprite there. Yeah, he just like released one that didn't get shown. What's that all about? Let's see if we can follow them. Like, he throws one, I see it. He throws one, I don't see it. He throws one, I see it. I mean, isn't there a thing right here? What? Alright, obviously some shit is still fucked up, but that is cool. That is cool. Yeah, there's an invisible one. Did I like hard code that one sprite per scanline thing? Like, I thought I took that out, but oh shit, my girlfriend's calling me. I'm gonna stop for a sec.